Myself, because brief introduction about me. I have around 5 years of experience in data science and analytics, and I have specialization in both machine learning and deep learning, and I have experience in both Java and Python. So, and I have worked in various development projects such as finance, manufacturing, retail, healthcare, and others. So today's agenda will be, we will briefly touch on what is data structure, those who don't know, and typical data structures in Java. Then what exactly is searching, then typical searching techniques. Then after our topic heading is binary search that we will see. Then thereafter we will see implementation and we will run a code. Thereafter we will see the conclusion. So now let us head to data structure. So data structure is very vital and important for any program building or any development activity. Why it is? Because storing and processing a data is very critical for any smooth running of app or any website. So arranging in proper manner and accessing it whenever is required without any hindrance, and designing which requires is data structure knowledge. So data structure is nothing but a combination of both simple and complex form, all of which are made to organize the data for a certain use. It can be very easy for users to access the data efficiently. That is nothing but we have to arrange the data in such a way that the user who want to access the data, he can access with very ease. There should not be any hindrance, that there should not be any hanging or something like that, but user experience should be very smooth. For that to happen, we should have a proper knowledge of data structure. So that is a very critical important point. So now let us head to the types of data structure in Java. Typically, there are like 8 types. There are a few others. I have considered top 8. So such as array, linked list, a stack, queue, binary tree, binary search tree, and heap. So you can see an image here. Okay, what is sorting? What is linked list? Linked list is nothing but it's linked to one other. List is nothing but it is linked like this. So and spanning tree, it is like a developing a tree. Then normal tree, that parent node and child node, then nodes like this it will go. This is a graph, and this is a stack. Stack is used for certain purpose, and hashing is used for certain purpose. So there are typical data structures which are used in Java for any developing activity. You name it, any app or anything. So these data structures should be there. According to the usage, we should use proper data structure so that time complexity is reduced. Okay, and space complexity is also optimized. So this is the main goal of the data structure in any language such as Java or Python. So now let us understand what is searching. In simple terms, searching is nothing but searching an item or a particle which is of our interest. So this is a basic definition of searching. But what exactly in data structure searching means? Searching means information, or finding information in a set of items, okay, which are stored in the form of elements in a computer memory. Obviously, for any program, the memory plays an important role. All the data which we build is stored in a computer in the form of memory. So whenever I want to retrieve the data, so I am able to write a program in such a way that it should be able to relocate in a vast amount of memory, and it should give me the result, proper results. So that is the main game of searching. It is nothing but it has to detect a particular item in a like a sea of data, okay, sea of memory which is stored in a computer chip. And also the main game is why we have to use the data structure, because while searching it has to consider the time complexity and space complexity. So that is our main game. And yeah, there are typical searching techniques are used, and these set of items are different forms, okay, such as array, tree, graphs, or linked list, which we have seen earlier. And another way of defining the searching in the data structure is by locating a desired element of a specific characteristics in a collection of items. That is what I said just now. So typically, there are two types of searching techniques. You can say one is sequential and interval search. Sequential is nothing but one after the another. Interval means we will divide into a group and then we will search in between the intervals. So these are the typical techniques of searching. What exactly is sequential search? The array elements are towered sequentially by checking every component of the set. That is nothing but every component is checked. The desired element is there in that set or not. Okay. So subsequently, it will go for one set to another. So it is goes in a sequential manner, one after the another. For example, you can think as a linear search. This is a sequential search. And what about the interval search? Algorithm designed explicitly for searching in sorted data structures are included in the interval search. That is nothing but these algorithms are more efficient than the linear search algorithm. For example, binary search, logarithm search. There are many. What exactly is telling that? In a sorted data structure, means the data structure is already sorted. Okay, then our work becomes easy instead of like a random data, or the data structure is based on the value, it is sorted. Then for example, if 1 to 10 numbers are there, we will sort it from lower to higher. So then if I want to search a number 5, then I will go from either end. That becomes the same. If I want to search number 3, then I will go from beginning, then I will search. It's a third position. So this is what a sorting will help. If it is all mixed number, then it is very like it is like a betting. Okay, I have to travels all. If I found at the first place, then that is a good. Otherwise, the time complexity and space complexity will obviously increase. So this is the advantages of having interval search over the sequential search. And nowadays, uh, proper specific requirement interval search is very helpful. And now we will come to know that binary search is very important. What exactly is binary search? We know that linear search is like a basic method. It is like a human skill. Okay, a human who want to search an item in his home or office. Okay, if he forget, he will search all the way, like from one basket to another, like that. So this is a simple way of linear search. And as I told earlier, binary search is very vastly used, and linear search is very rarely used. And in Java, typically there are two approaches for using a binary search. One is iterative approach, another one is recursive approach. What is iterative and recursive, we will see in a while. And also we will see the implementation using a Java program. And first we will understand how exactly the algorithm goes, okay, for binary search, okay. So binary search is nothing but we have to search in a sequence. First what we have to do is we have to calculate the mid element of the given array, okay. Then you have to make a comparison of key element with the mid element, whether mid element is equal to the desired element. If not, otherwise, if key element is equal to middle element, then you will return that, yeah, the element is found and the function terminates there itself. If not, else, if key is greater than mid element, then the key lies in the right half of the set of array, because this is a sorted array. So thus repeated steps will happen, then it will go from lower to higher, then it will find the array there. If not, then we have to understand that the array, the element is not in the other half also, because it is a sequential. This is how algorithm for binary typical, you can say theoretical algorithm, how it looks like. Now let us understand with the one example. Here I have taken an array of 10 elements. Okay, you can see 0 to 9, and most of you know that numbering starts from the 0. We can change it to 1, but the default number is from 0 to 9. Before doing that, as I said, binary search takes like a sorting. So this array is in the form of sorted array. Otherwise, we used to write a small program where we will sort the element first, then I will come to the steps. So assume that we got a already sorted array. Okay. So now what is the second step? I have to calculate the mid of the value. Okay. That is nothing but the number, position number, not the element number. Okay. The position number. So 0 plus 9 divided by 2. That is nothing but 9 divided by 2 is nothing 4.5. So I will take it as a 4. This is my midpoint. Okay. So now, for example, if I want to search an element 21, okay. And once I got to know that fourth is a mid element, and what is the value of that fourth value is a 21. So I desired element is 21, and my what is the mid value found is also 21. So here itself is the position is found, and we can mention that the key value is found and it is in the position fourth day. So that is how. If it is not, then what we have to do? For example, if I want to search another element, okay, for example 25, okay, then where I have to move, as it is a sorted array, obviously the 25 lies to the right of the list. Okay, so that is how we have to check. It is like a human mind calculation, simple. So then again I will repeat the step. I will take the mid and high, sorry, low and high. Then I will take the mid value and I will check whether the mid element is there. If no, then I will go to the next. Then I will take low plus high divided by 2. Then I will try to find the mid. For example, if it is 54, then I will tell, okay, the element is in 8th position. If not, then I will return, after all searching, I will return that the desired element or desired value is not present in the given set or array. Okay, that's how a binary search works. Okay, so the typical steps what I told is we have written here. So until unless we repeat this element, until unless we reach the end or we found the element, because a binary search is more efficient in terms of time complexity and correctness, and it is quick one too also. So this is why it's a more important in development activity, and it is widely used all over the world. Okay, now let us understand the implementation. As I told, there are two types of binary search. One is iterative, another one is recursive. Okay, why there are two types for the same logic? It is just because to optimize the space and time complexity. Now, what exactly is iterative search? Okay, what exactly they are used in iterative, or what exactly they are used in recursive? Typically, what happens? It's a if and else condition is used in iterative. Okay, and recursive happens. It runs in a loop. Okay, until unless the desired output is achieved. Once it is achieved, it will come out of the loop. Okay, it will not take from the beginning step again. But in iterative steps, it takes from the beginning step, and it will take some time. But recursive is very time efficient. Okay, there are typical some differences I have listed down. You can see it. That iteration, it is a process of executing statements repeatedly until some specific condition is specified. That is some specific output or a item or 20, as I said in the list, the 25 number I want. So that is what. In recursion is technique of defining anything in terms of itself. So recursive is not, it repeats itself. That is the word meaning. It happens until in itself, okay, until it finds the desired result. That in what happens in iteration is there are four clear steps, that is nothing but initialization, condition, execution, and updating. So this is the steps which are used in here. And there must be an exclusive if statement inside a recursive function specifying stopping condition. That is if the desired function is achieved, then I will write another small function that if this is achieved, then please stop the execution of the process. Otherwise, what will happen now? The loop continues, go on to infinite loop, and it will run for all the time. So then that we have to take care while writing a recursive function, and we will see on recursive function using both iteration and recursive function in Java. Okay. Any recursive problem can be solved iteratively, but the main problem is that not all problems have recursive solution. Okay. Whatever the recursive solution are there, we can solve by using iteratively, but not all problems has a recursive solution. That is one disadvantage of recursive. Okay. And iterative computer part of a problem is more efficient in terms of memory utilization and execution speed. So generally, as I told that earlier, iteration is like a more efficient, but recursive is generally worst option to go for a simple program or problem not recursive in nature. It's very specific case we have to use the recursion. Okay, for simple and time consuming, sorry, it's simple and time saving and energy efficient, we can always go for a iterative method. So these are typical two types which are used in Java. Now we will head to the implementation part. Okay. Yeah. Now let us come to this compiler. This is an online compiler. I have used a website as a Java T point. Okay. So here what is happening is you can see this. Okay, I have written a simple binary search example function. Okay, I have written a class. Okay, inside that I have written a binary search where it takes input as int I mean to say array, and integer, this is the first and last, and the search key. Okay. The logic goes like this: if last element is greater than or equal to first, okay, then only the int of mid is equal to first plus last minus first divided by 2. So then I will get a mid array. Okay, this will return a mid. Okay, if array of mid is greater than key, if array of mid element is greater than key, what will happen? It will get into this. Okay, and it again the function will run. Okay, and thereafter what will happen? Otherwise, it will go to the else. Then the second of it will search. In both the cases, it will run in a loop. Okay, if not, the element is not found, what will happen? It will return negative. Okay, so now I have taken one simple array example. Okay, I have called the function here. Okay, so here what I am defining, as I told earlier, that it takes a array, integer, initial, last, and key value. Okay, this is my array. Okay, 10, 20, 30, 40, 50, and this is the key. Okay, then here the int last is equal to array length minus 1. Obviously, it's because it starts from the 0. So this is the last minus 1. Okay, so that's how. Now I will call a function, my binary search function from here. Okay, this binary function when I call here, then it will take a array, int, last, and key. So all the elements are given here. Array is there. The initial position is 0, and last is length minus 1, and the key value I want to search is 30. If result is equal to -1, means if the element is not found, then the given output will be element is not found. Otherwise, if element is found, what we will give is element is found in index so and so, and it will show the result. Okay. Now we'll try to execute this. We can see here the element runs. Okay, I am trying to search element 30 in this case. Yeah. So now you can see that element is found at index 2. Okay. See, the same is written here in the form of string. Element is found at index 2. 2 is nothing but 0, 1, 2. As I told, it starts from 0, 0, 1, 2. For example, if I change it to 20. Okay. Now let us run. What it should give is 0 and 1. So element is found at index 1. For example, if there is no item, for example, 100 is not there here. Okay. I will try to search. What it should do? The element is not found. Obviously, there is no element in 100 in this given array. So obviously, it should return element is not found. This is how about a binary. So this is what we have seen is a recursive method. Now we will see iterative approach. Okay. The concept is same, but here what it happens is it is an iterative process. So it will take mid value first and last divided by 2. Then while first is less than or equal to last, then what will happen? It has a condition. If array of mid is less than key, then first is equal to mid plus 1. This is simple mathematics. If not else, then array of mid is equal to key. And then what it will use? It will tell that element is found at index so and so, and it will break the loop. If not else, if it is not found, it will go and tell that last is equal to mid minus 1. Then again the process will repeat, and first plus last divided by 2. Then if it is also still not found, then it will say that element is not found. Okay. So now we will take one example similar to that what I have taken earlier. So here is the thing that I want to search element 20. Okay. So it should give an ideal position as 0, and because this is 0, 1, 2, 3, and 4. Okay, there are 5 elements which index starts from 0. Okay, when I run this, and it should give me a position of index 1. As I see that this is giving a index position of 1. So this is how we have to search. For example, if I take again 50. Okay. So now you can see that the index is 4. As I told, its index position starts from 0, 0, 1, 2, 3, and 4. So this is about. And if I mention 500 also, you can see, guys, what should it give? It should give that element is not found. The basic idea is that I have written a logic here in this. Okay, and it is giving output based on my function. So I have just combination of recursive and iterative method of Java for the binary search. Now let us head to the conclusion. Generally, I said binary search is most frequently used searching technique in Java. And because searching in these techniques must be done on sorted data only. As I told this is only used for data which is sorted. On that only we can apply. And a binary search can be implemented either using iterative or recursive approach. Okay, there are two ways. One is iterative, one is recursive. Iterative is goes from one point to the another, like high and low plus divided by 2 and mid, and it will search there. Then if it is not there, then it will go move to right and left based on the input value. And recursive approach is that it runs in itself. Okay, it recursion happens until unless the optimized result is found. Okay, and arrays class in Java also provide the binary search method that perform the binary search on an array. Okay, there is another class which you know that arrays, which also provide this binary search option, which we can implement using array also. But this is a very simple and effective option. As I told that iterative is more, you can say, system friendly and environmental friendly because it consumes less energy. So this is all about binary search using Java. So thank you all. Thank you for joining.